Hello, everybody. So I hope everyone is doing well. I just want to make a quick video on web scraping, which is a part of the starter project of web scraper DataDive. So I hope everyone has a chance to kind of look through the project and understand what the overall objective is. I'm going to go over the web scraping part because it is one of the, I would say, more difficult tasks to do. And yeah, let's get right into it. So to start off, I just want to go over what web scraping is. And its simplest definition is a process of extracting content and data from websites. So I'll give you an example. So I have this website over here. It's called quotestoscrape.com. And web scraping, what it does is it goes to this website, a scraper would, and it would take data from here. So what it could take would be the quote, the author, maybe even their about section about them, tags associated with the quote, and other information if it's available. Another example would be what we're trying to do in the web scraper DataDive. We're trying to go to startup jobs, um, search up search up a specific theme of job, and scrape these job postings. And the data we get from scraping these websites can be used for other tasks. So there are two major libraries which are kind of used for web scraping. There are more, but these are two major ones. The first one being Request and Selenium. So these aren't entirely developed just for web scraping, right? They have more purposes. Request is used a lot more outside of web scraping, and Selenium is used a lot for automation as well, which is kind of related to web scraping, but isn't completely. Um, I just want to go over the difference between these two. So request, as I mentioned over here, is mainly developed is really good for if you have static websites, right? It's fast and not very resource intensive. So what I mean by a static website is something like I had over here, Post to Scrape. There isn't content being dynamically loaded in. And I'll show you an example of content being dynamically loaded in, which isn't static, is Unreal Engine's forms. So I just want you guys to pay attention to the scroll bar, and you'll kind of get an understanding of what I mean when I say content is being loaded in dynamically, so not static. So just keep a look at the scroll bar. So as you get closer to the bottom, you're going to see that the scroll bar is right over here, pretty close to the bottom of the page, but there's still about 100 posts left. So when I keep on scrolling, you're not going to see that just instantly the scroll bar is back to the middle of the website. Looks like it's back to the middle of the website, and that's because more posts were directly loaded in, and that's called data being dynamically loaded in, which isn't static, and it's something we would use Selenium for, which can handle this dynamic aspect of modern day websites. So another library which we're going to be using is called Beautiful Soup. This library kind of isn't necessary, especially if you're using Selenium, because a lot of the functionality of Selenium, of Beautiful Soup actually can be replicated in Selenium. However, just for experience purposes, it's always nice to use. And it's essentially a library which makes data extraction, so extracting text such as this from websites a little bit easier. To store and clean the data, we're going to use a general data science library, or this is at least what I do. You guys can take a totally different path if you want to. Pandas, a general data science library, which allows us to convert the information we collect into a CSV file. And when we get our raw data into a CSV file, we can again use pandas and other libraries to clean and manipulate the data to our needs. So finally, according to the Star project, our goal is to web scrape startup jobs, or one of our goals is. So I'm just going to close these real quick. And this is a website. You could take a look around. It's not too complex when you look at it on the surface. And you can search different like job themes up, right? So that's kind of our goal, to scrape a specific theme of job. So for example, I can just search job machine learning. And a bunch of jobs which are related to machine learning will pop up. You can see their title, company, the associated tags, and the location. And this applies for other fields as well. So data science, again, more job show up. So first off, before we even get scraping the website, we need to make sure it's ethical for us to scrape this website according to their rules. So lots of websites have something called robots.txt, and essentially a file which specifies which user agents or which web pages can you scrape and which ones can you not. I'm not going to go into depth on how to read these types of files, but there's guides on the internet. You can definitely just search it up when you need to. Yeah. So based on this robots.txt, it's essentially saying that this user agent, which we're not using, cannot scrape these pages, but pretty much everything else should be allowed. Okay, so our first step, picking a specific theme. I'm going to choose. I'm actually going to choose data science. So I'm just going to go quickly. Understand how job postings are loaded in when searched for. So yeah, we can see they're kind of dynamically loaded in. Um, so they essentially just kind of pop in a way. And what else? And we need to take a path to web scrape. So there are multiple paths we can take to scraping the site. Um, One way is that we can get all the links needed. So if you click on these, you can actually see their links. And when you click on these links, it opens a new web page which contains data about the job, its location, and so forth. The one way to do this is that we could get all the links needed, then scrape through each link we have and store the data. That would look something like this. We open this, or we don't open it. We store it. We store this link. We store this link. We keep on going and storing as many links as we possibly can, or we want, and then go through each of those links. So each of these web pages and extract the data, such as the title, the location, the description. Path B is get the link. So this is a little bit more straightforward. We we get the link. We get the link. We scrape it, and then we move on to the next thing. So the difference is that one, you're kind of not scraping all the data till the very end, but in the other way, we're kind of scraping everything at one single time. In path C, this is kind of a hybrid of both. So this one, you get multiple links. So let's say we get the amount of links on this page, right? We scrape through all those links, we get the data from each of those links, and then we show more results to get to the next batch of jobs. And it really depends on which path you want to take. I generally try to take the one which is easiest because I don't really see a huge time difference taking the different paths. Some of them, one path is just a little bit easier than the others. So yeah, I'm going to see which path we take while writing code. And finally, we want to convert all our stored data into a CSV. Okay, that's pretty much it for the overview. This is something at the end, which I want to go over. So let's get started on coding. Okay, so I know I said that we get started on coding immediately, but there is a couple of steps which I myself forgot, which is kind of my bad. So the first one being is that you can't immediately start web scraping without installing what is called a WebDriver. And WebDrivers are essential to being able to web scrape with Selenium in particular, but I also imagine with other libraries as well. So to install a WebDriver, there's different types. I've installed a Chrome WebDriver, and to that you can just search up Chrome WebDriver install. And you're going to be led to this page, WebDriver for Chrome by Chromium. And on this page, you want to go to the download section. And when you go to the download section, you're going to see a bunch of installs available. You want to make sure, in this case, you have a similar version of Chrome driver or of Chrome to the Chrome driver. So what I'm trying to say is, if you look at your Chrome version, which can be found by putting this into your URL bar. You're going to see that your Chrome version is right over here. And in my case, it's this. So what you want to do is you want to install a similar version of Chrome driver from this page. So in this case, I'd probably install this one because it's the closest which I can find. And you can simply download this. I'll download it again, since even though I already have it installed. Extract it, and which you can do. And you're going to have a new folder, which is going to be Chrome driver, which is going to be labeled Chrome driver. And all you have to do is get the path to the application. So it's going to say Chrome driver, type the file as the application, and you just want to copy its path. Now let's put that up here for later use. Second thing which we forgot was that your environment or your working environment might not be set up properly for the code I'm going to write. So we're using libraries such as Beautiful Soup and Selenium, and those actually can be installed through pip, which you can install with, you can just simply type pip install bs4 and it'll start installing for you. So you have to do this in the terminal. I also recommend that you use an IDE instead of just simply a text editor, like a very basic text editor, such as Notepad. Since all this is easier to manage using IDE. But other than that, I think I've covered everything, and we should be ready to go. Okay. Start off, we want to install the different libraries that we need. So one library that we need is going to be Beautiful Soup. So to import that, we can do from PS4 import Beautiful Soup. Another library that we're going to need is Selenium. So from Selenium, and we don't need Selenium in its entirety. I just need some aspects of it. So we can just import what we need. So we need the WebDriver functionality. What else do we need? We also would probably need Time. Time is a library which allows you to kind of tell a program to stop at different intervals, keep track of how much time has passed, so forth. And yeah, I think that's it. So I'm going to do this in an object-oriented way, which I know some of you may not be familiar with. If you aren't, then I can definitely go over it with you and help you kind of rewrite it in your own way, which is procedural, which is totally fine. Just tell me if you need that type of support. Or you can also go into ChatGPT and copy paste my code in there, and in there you can actually you can ask ChatGPT to write my code in a procedural format, and it does that pretty effectively when I last tested it. So yeah, those are your two options. Okay, so I'm actually going to start the code now. So first thing I'm going to do is create a class, and I'm just going to call it Startup Job Scraper. Startup Jobs Scraper. And in this class, you want an init method. An init method is a method which runs immediately after an object is made from your class. So how many different parameters this takes in, which this class needs to take in. I'm still leaving this like as empty for now because I could always change that later. And I'm gonna set up those things which I know we're definitely gonna need. So we're gonna need a tracker of how many jobs have been scraped. And we can set that equal to 0 because at the start of the program it's gonna be 0. The number of jobs we need, which is going to be needed to take it in. So it's going to be parameter jobs needed. We're going to need a list, and we can call it data. So I think the way that I'm going to do it is I'm going to have a list, and this list is going to contain a bunch of dictionaries, and each dictionary is going to be equal to one job. So what I mean by that is that each dictionary is going to have keys, such as the job title. I'm making this up on the spot right now, and that job title is going to be associated with the actual title of the job, and so forth. We could have job tags. That's going to be associated with the tag of the job. Because we'll see this in action later. I'm just going to create an empty list for now. We also want the topic. The topic, I referred to as theme before, pretty much the same thing. It's just what do we want to be searching for? So we want to be, so for example, like if I want to search for machine learning jobs, the topic will be machine learning. I can put it up in here as well because we can pass it in. Um, Finally, the last thing we need is that we could have a variable called browser wiz. And this is just essentially sets the browser to be visible while scraping or invisible. So yeah, and I'm gonna send some default values to these parameters. We'll do the default if we don't pass anything in. So it's like so there is a little bit more of setup that we're going to need to do. In the edit method, I also like to set up my Chrome driver and like going to the actual website. So I'm gonna set that up as well. Well, I'm actually going to get the URL. I completely forgot what it was. The base URL, the website which you're visiting. Um, what else? Let's set up the Chrome driver now, I guess, and the Chrome options. The self-web driver, which is going to contain our web driver essentially. Um, WebDriver.chrome. So we're specifying which type of WebDriver we're using. And I actually forgot to create a service object, which is my bad. So above this, we actually need a service object. A service object just kind of points to where the WebDriver is. And we can create that really quickly. And we're going to need to use the path we stored up over here. Service. And we can simply copy paste this into here. I actually forgot to import that as well. So that's something that was missing. Import that. Okay. So essentially, the service object is going to be passed into the WebDriver. It's going to be passed into this, and it'll allow us to use the WebDriver which we have stored. What we also want to do is create options for a WebDriver, and it's kind of just like basic configuration. So in this basic configuration, I generally don't do too much. I just like to make the browser in incognito mode so it doesn't interfere with my other stuff. I also like to disable geolocation. And disabling geolocation, sometimes websites take your location into account while like displaying content to you. So we didn't really want this bias, right? Yeah, it did. We can put that into our function over here, pass it in as options. So C option. be lowercase. Yes, there might be something wrong with it over here, but hmm. Oh yeah, I spelled it wrong there. That's why they did it. The basic setup should be complete unless I messed up something. Oh yeah, that was me from before. This, I forgot to create the object. So this should work. Yeah, as you can see, the website opens. I added time.sleep over here to make it sleep for 2 seconds because if I didn't have this over here, the browser would actually close immediately. So time.sleep just allows us to stay a little bit longer so we can actually perceive that it opened. Okay. Now the next step is creating a function to get the different jobs and the different links. Time.sleep up there just to give it some time for content to load in. You can also use self driver dot implicitly wait, which essentially you set an amount of time for it to wait. So it waits 5 seconds for content to load. If the content is already loaded in, it's not going to wait those 5 seconds. It's going to cut it short. But I often have trouble with using this, so I'm just going to leave it for now. I'm just going to talk about sleep. So what we want is while the number of jobs we needed is not equal, it's actually, we can do greater than or equal to self.job script, actually just be greater than. Then we want to run this code. Okay. Actually, there's one thing up here I forgot to do as well. So currently all our code does when we create the object is go to startup.jobs. In the init method, this is up to you as well. You could also have it so it immediately goes to the content you need. So let's say I wanted to go to data science. You could have it set up so it immediately switches this up. I'm gonna do it that way just because I find it a little bit easier for myself later. And yeah. So what we're doing right now is we're telling the WebDriver to find a certain element. Elements are just parts of an HTML page, which you should have a basic knowledge on by now. But essentially, there's kind of parts which make up an HTML page. So input's an element, a div's an element. It's kind of a universal term. And what we want to do is that in this case, we want to find the search bar and input keys into it. So we want to input actual information. And the best way to do this is through an ID because IDs are always unique to the page. They're simple, and Selenium has strong integration with them. And as you see, we have an ID over here for our input, our search input, and we can just copy this. What we're doing here is I need to import this as well. Sorry, I keep on forgetting to import some stuff. Is that we find the element by a specific ID. So in this case, it's query. And query is our input box, which we need to add information into for jobs to show up. So what we can do is we can find the element by an ID and send keys, which of self.topic. Self.topic is passed in, the default value being data science, So if you run this now, here, if you run this now, it should input data science into the input field. So you can see data science and loads in as well. All right. But okay, so we made some progress. We're now at the page which we need to collect data from or get job posting links from. Now's the process of actually getting these links. So every iteration of this loop, let's say that we're on a new page. So how startup jobs works is that you search up, for example, machine learning, it shows you about 25 jobs. You press show more results, it brings you back to the top of the page, and you get 25 more different results to go through, and so forth. So what we want to do is that we can kind of collect 25 jobs at once. And then every new iteration of this while loop, we can collect 25 more. So essentially, every iteration of the while loop is a new page, if that makes sense. So let's get started on that. Over here, I'm just going to add a quick print statement of the number of jobs selected. And it's just going to be the number self.jobscrape, so number of jobs scraped. You can also add a percentage if you want to. So self.jobscraped divided by self.jobs needed times 100. So this is going to give us a percentage of how much has been done. And we're going to end this print statement off with 2/n characters. So this just adds spacing. Okay. So next thing we want to do is we want to introduce Beautiful Soup. So as I mentioned before, we can do this without Beautiful Soup, but Beautiful Soup makes it a little bit easier, in my opinion at least, and it also gives us the experience if we need to ever use Beautiful Soup in the future as well, because Selenium does have the functionality to do lots of work without Beautiful Soup, but Request doesn't. And if there's ever a case where you decide to use Request, you're going to need this experience. So let's set up Beautiful Soup. Beautiful Soup. Okay, so and in this function, let's add page source. So the driver gets a page source. And we specify which type of parser it's going to be. So HTML.parser. Okay, let's go back to this web page. Let's click inspect element. So what I'm thinking right now is that there should be a way for us to collect all these job postings, so the HTML code, and just put them in a link, or not put them in a link, but put them in a list. And we can go through this list after that and extract all the data we need. That's kind of my approach to doing it. You could think about it a totally different way. So let's get started on that. The first thing we want to do is we want Beautiful Soup, which now has an HTML code or current HTML code, to find all the different. Oh no, yeah, it's going to need to find first the actual div which contains all the job postings, right? So if we kind of try to find it, we're going to notice that there's two major divs here. There's one which is called hidden, which is just default text, I guess, and another one which is our job postings on this page, which is what we need. So we can get this by specifying that we need to find the div, the element that we need to find is div, the class it has. Something a little bit different about startup jobs, or not different, but a little bit harder to deal with, is the fact that the class names are essentially just ways to style the elements. And these class names can be used all throughout the website. So if you tell a beautiful suit to find flex, it's probably going to be able to, it's going to pick up this. It's going to pick up all these job postings, but it's also going to pick up stuff which you don't want it to. What if flex, the specific class we're referencing, is being used up here somewhere as well, or somewhere down here where we don't want data from. So we need to be careful and really specific with what we want using Beautiful Soup. What I try to do is that I try to pick a class or some sort of attribute which Selenium has good integration with that is that looks unique. So this looks pretty unique to me when you're trying to reference it. So I'm gonna try getting the element using this class, right? So we're finding a div where we look for this class, but I also want to specify an attribute. And the reason I want to do this is so that I don't run into the issue, as I mentioned before, of it finding multiple elements which I don't want. So the attribute which is special about this is that it has something called data search target, which I actually haven't heard about. I'm pretty sure it's unique, or something which is a custom attribute to this website. And it says data search target is equal to hits. So let's just reference that then. Okay, so what this did for us, or what I'm assuming it did, is collect the entire div which contains all these job postings. So we don't have all the job postings. We have the div which contains them. But we want the job post, right? So we want the job post in the list. So the next thing we can do is we can just find all. And with find all, you can search for divs again because all these are divs. Every job posting here and the link associated with it is a div. So we're going to have to find divs again. But this time we're going to search for a different class. We're also going to search for different attributes. Okay. So something that we could search by, which I feel like is more unique to these job postings, is grid-coals.6. Again, this could be somewhere else on the website, but I feel like it's going to be used less than something just like simply as grid. So I'm just going to copy this. Set the attributes. And again, I'm searching by custom attributes because I don't want the scraper to get information which you don't want it to. So this element's unique attribute is data mark visited dash target. And we can copy this. And in this case, it says container for some reason, which I'm not sure why it does, but it should be able to collect this now. So let's print this out actually. So let's run our code and print out job posts. And let's see what it does. Page links. It's not going to get page links right now, but it will get all the job postings, I think. Okay. Ooh. Some small. Oh, yeah. That's just me. Not paying attention. Okay. So as you can see, it's continuously printing out the data it's using the page. This is because it's stuck in an infinite while loop, which this won't happen in the future, but this is the data it's collecting, and hopefully we can see some patterns with what we're looking for. Yeah, so it says data science up here. Hopefully I can find a specific title maybe. Actually, let's do it this way. I was actually looking for machine learning. I kind of must do data science. Model governance. Let's search in here model governance. Yeah, so we found the HTML code that we were looking for, right? So we can tell that this is a title And this title came from the HTML code in this section, which we have collected. So far it looks good. If we run into issues, we're going to know them later when we actually have like the text data. But let's keep on going. Okay, so now for every job and job post, remember currently I'm going to call it H jobs because it's not really a job posting completely. It's like HTML, which we're going to parse through. Let's get the job link first. So get the job link. We can do this. Okay, so we need to find each link of the jobs. Okay, so we're going to search for A attributes in our HTML that we were given over here. So remember, each element in here is just a bunch of HTML of one job. So we can extract the link from this. And what I mean by link is the actual link you click on when you're trying to go to the job page. And as you can see, that is stored here. Yeah. So it's stored in the div. One of the classes that I could probably use for this is PT1. Again, it's probably used all over the website, but it just helps us narrow down our search. PT1. And the attributes which I can search by, the custom attributes I can search by is data mark with the limit target. Okay. So what this should do is just print out all the job links that we can collect. And remember this code, you'll know if we're on the right track. Okay. Yeah. This actually looks okay. But I think the name is a little bit misleading. Let's call it job link job a HTML. So what I mean by this is essentially what I'm trying to say by this is that it's collecting the HTML around the A link, so the HTML around the A tag, as you can see over here. So the A tags always contain links, and yeah, so we have the HTML kind of filtered down. The next thing we want to do is we want to create a dictionary. So I mentioned before that the way that I want to do it is that I want a list with a bunch of dictionaries in it, and each dictionary represents a job. That's one way you can do it, and that's the way I kind of choosing to do it. And one of the first things we're going to need is a link, right? So we're going to set up the key link, and that's going to be the URL and the actual link from the job. Because as you can see from over here, it's a little bit cut off, but the href tag actually references the actual link, and it doesn't start with startup jobs. It immediately goes to the actual unique path from over here. So it completely ignores this section. And we don't want that because our scraper can't really understand that if we're going through the links again. So we're going to add the base URL to the job, we're going to add the base URL to the link that we've collected from the actual site. What else would we need from this? So something that I noticed, which is kind of unique, is that what we also need is we need the tags. And this is one of the reasons I try to take, this is one of the reasons that I decided to use a dictionary, is because when you click on the actual page, you can't see the tags which are associated with the job, right? These are the jobs, ignore this. But you can't actually see data science or senior. And we probably want to collect those as well. So instead of only doing the links, let's try collecting the tags as well. But I'm going to leave this a challenge for you guys. For you guys to try. So the format that we kind of wanted in is we want a list of tag 1, tag 2. So obviously it's not going to be this, but like let's say you scrape the first job over here. Does it have one? Yeah, it does. You scrape the first job. Your tag one would be data science. Your tag two would be senior. For this, your tag one would be stats. Your tag two would be data science. For tag three would be executive. Okay. Okay. So self.data append job dictionary. So what we're doing right now is the overall list we have called self.data, we're appending a dictionary to it. And this dictionary is called job dictionary. And it actually indented wrong for this, so I need to fix that. But we're essentially currently what we're doing is we're appending a dictionary with the link and the tags. What we also want to do is, since it's going through each job posting, we want to add self.job scraped plus equal one. Looking back, this variable name is kind of misleading because we're not actually scraping the jobs, you're only collecting their links. So I might change that later. Hey, okay, so let's run this and let's just see how it's running right now. Outside the for loop, I'm just going to write print self.data. I'm actually going to change this real quickly as well. Oh yeah, I should have changed that more. I should have refactored that, but it's fine. Okay, so let's print this. I mess up something. Um, we got a comma. Or not comma. Yeah, comma. My bad. Okay, let's see this. So we collect the link. The tags we can ignore. There should be 25 of these. Let's print the length of stuff.data. And we should see about 25 because there's 25 jobs over here. So it should just say 25. And that's exactly what we needed. Great. So currently all our scraper does is it collects from the actual it collects from one page. So we need to set this up so it can scrape from multiple pages. And the way I'm going to do this, I'm going to tell the driver to scroll down. Yeah. So after you're done collecting all these jobs, and so we're collecting their link and their tags, you can click on show more results and that'll bring us to the next page. Now I'm going to do this. I'm going to tell the driver to scroll down to the bottom of the page. Yeah, scrolling to the bottom of the page won't isn't as effective as scrolling to a specific element. So I'm gonna go back and change my code a little bit because the problem I'm running into right now is that I want to click this button at the bottom of the page, and that's pretty simple. Collecting the button path or collecting a specific identifier for it, clicking it, and then moving on, right? The problem is if this button is out of focus, it's going to give me error. So it's going to say, so if I try clicking the button, it's going to say element click intercepted, or it'll give me a stale element exception, which occur when element that needs to be interacted with is not directly in view to the driver. So what I'm going to do is I'm going to set a variable up here. I'm going to call this view button. That's going to be equal to something to find element. That's going to be equal to us finding an element, and we're trying to find this element, show more results. But if you notice something with this element is that it doesn't have an ID. It does have an attribute, and it does have href. So you could search this up the traditional way, but another way which I want to show you guys is copying by XPath. So in cases where it's really hard to identify a specific element and you have no other way of really doing it and you're kind of stuck, there is another way called getting elements XPath. And the XPath is kind of a mapping of where an element is located on the page. So in this case, it won't be that difficult, but it definitely be. But if you're ever in a situation where you're definitely sure that this is really hard to do, getting a specific element, just do it by XPath. It is a kind of a impreferable way, but still works. So I set it up so as soon as the page loads, or as soon as we start scraping, we have a variable called view button, and it references this button, which is at the bottom called show more result. And what we want to do is we want to scroll this element into view. And we can do this with this JavaScript code, which we can inject through the WebDriver, or we can execute through the WebDriver. And when we scroll down to this view button, after that, we can click it. And that should bring us to the next page. Let's see. Okay, so I think I know what I did wrong. I said the job needed just a 10, which I should have changed before. Let's set it to 100. Hmm. Maybe the content isn't loading in on time. Okay, I'm just debugging. Yeah, that was the issue. Okay, so the issue that we ran into right there, or that I ran into right there, was that essentially I clicked show more results, but I didn't give the time for the web page to load in. And me adding time.sleep over there gave the page time to load in and allowed us to continue scraping. So yeah, it's more of a content loading thing than something wrong with my code. But yeah, it seems to be working. It seems to be collecting multiple links. If we actually print it out, so this should return self.data, which should be like ascending in order. So every time it gets printed out, it should increase by 25. This should print out the length of it, just so we can confirm. Yeah, let's see this. Yeah, so 25, it prints out self.data, and there is a significant length difference as well. So seems to be working now. Great. So something that I want to try is what if we set this to like 1,000? And this is something which you might run into where a site might not have enough data, or you set your expectations too high for the amount of data there was, and it kind of just crashed on you because there's no more data to scrape. And I think this is something which will happen to us as well because now startup jobs, if you look over here, it only has about 300-ish jobs, approximately 200, 300, somewhere around that. And we're going to run into error really soon because we asked for 1,000 jobs, but in reality, there's only about 200 which we can actually scrape. And there you go, ran into error because we ran out of jobs to scrape. And it just continuously keeps on trying to do that. So yeah, something that we're going to do is, one way to do this is to check if the button is there. And that could be a little bit more difficult because if they decide that if the web page is made in a way which the button is actually hidden instead of completely removed when you run out of jobs to scrape, or like when they run out of jobs to show you, then that could be an issue. But a simpler way that I like doing it, it may not be the best way, um, is importing errors. So what I do is I import from Selenium common exceptions, the error which I got, so element not interactable exception. Yeah, we need to fix this. Import the specific error, and if this error goes off, we kind of know that, okay, we ran out of those jobs, which is great. Let's try this. Got trouble matching them up, but it should be fine. And we accept the element not interactable exception. And in this case, let's just say the max number of jobs on the site. The site has provided is up the jobs button. And yeah, so over here, this will run when the link selection is completed, and we can also print out the number of jobs which have been collected. Hey, that should work. So essentially, if it runs into error, that means we know that that we ran into the maximum number of jobs the site has provided, which means there's no jobs left for us to scrape. And in that case, it's going to print this along with this. If we only scrape for maybe 100 jobs, then we're going to have this printed only. So link collection completed, but not this where it warns us that there's only a certain number of jobs on the page. One final thing. So currently our scraper is set up so it scrapes 25 jobs each time. So since each page or each time you press show more results, there's 25 new jobs that come up. We're going to be going up by multiples of 25. If we specifically want a number in between that, we could set it up so it does this. Set self.data to kind of cut itself off at a certain point. Self.data has a list, and we only keep, so what this does, it only keeps elements, only keeps a number of jobs with the number specified. So essentially, it'll restrict us to, let me remove this, to only 100, to only 99 jobs in this case. It won't go to 100, even though technically our scraper is going up by 25. It'll cut off the last job to make sure we reach our number that we want. This is completely optional, and there's really no purpose for this. But if you want it there, it works. Fine. So the link collection was pretty hard. The scraping of pages isn't too difficult. So I'm actually going to make this a task for people who are interested in trying to complete it. What this does is that in our software data, which contains dictionaries, we set the software data which contains dictionary, we look at each, or we grab each dictionary and get the specific link to it. So we tell our driver go to that specific link. I'm actually going to run this code first just to show how it works. We just prove that it works. Okay, let's do this. Where is this error? Yeah, and as you can see, it's running pretty fast as well. So about every 2 seconds or so, it's getting 25 jobs, which is a good rate. Yeah, so these percentages, I'll leave this up to you guys to figure out how to run these. But as you can see, it's working generally, in general, and we have all the data stored in our list of dictionaries. And you can actually click on these and go to the specific um, jobs which is specifying. Great. A couple small changes over here. Finally, almost done, or I'm almost done. But now what we have to do is we go through each of the pages or each of the jobs you have stored, and I'm going to leave this up to you guys for you to scrape the description. So I'll actually show an example right here. The description, all of this, the company name, the location, the job type, so the full-time or full-time, part-time, stuff like that, and any other information you want from over here. But I feel like that's pretty much all of it. I want you guys to update the same data structure provided. So instead of creating a new dictionary and or creating a new place to store the data, just update self.data, the variable I've already set up. Okay, so that's the task for you guys to do. Finally, the task up to you guys is to save to CSV. It's not too difficult. My suggestion is use pandas. As I mentioned before, pandas is a general data science library, which is really useful, this type of stuff. You're going to use it a lot in data cleaning as well. And finally, my last task is set up a way. So as soon as you're done completing all of this, what was my overview again? So as soon as you're setting up the tag system, getting the description, figure out how to store the data in CSV, um, I want you guys to try setting up multiple scrapers. Set up so like they're running at the same time. Yeah, so these are just two different ways you guys can kind of approach it as well. And finally, kind of the most important part is maybe trying to figure out how to optimize my own code. So I know my code's not perfect. There are definitely some ways which can be a little bit more faster, maybe and more efficient. So that's kind of my challenge for you guys to figure out how to optimize my code. Okay. So if you guys need help, there's lots of resources provided in the DataDive starter project description. Um, If you guys you can reach out to me as well, my tag is simply at Silshan underscore Sundu on the Stemway website. Feel free to ping me and get in contact with me. And yeah, I think that's pretty much it. See you guys.